determining the ratio of division. Now, if you look at the first point on our slide, you'll recall that in our previous lessons, we focused on a specific direction. We knew the ratio of division, and our goal was to calculate the exact coordinates of a point P. However, today we are going to flip that logic around. In many real-world mathematical problems, we aren't starting with the ratio. Instead, we are already given the coordinates for the endpoints, A and B, as well as the coordinates for the point P that lies between them. Our task now is to work backwards to determine the specific ratio in which point P divides the line segment OB. Welcome, everyone. Let's begin our new lesson on determining the ratio of division. In the next slide, I will show you a clever mathematical trick to make solving these types of problems much easier. Understanding the concept. Imagine we have a line segment connecting point A with coordinates x1, y1 to point B with coordinates x2, y2. If we place a point P with coordinates x, y, anywhere on this line segment, it naturally splits that segment into two distinct parts. In mathematics, we describe the relationship between these two parts using a ratio, which we usually write as m1, m2. Now, here is a professional tip to make your life much easier. Instead of juggling two different variables, m1 and m2, we use a clever algebraic shortcut. We assume the ratio is simply k, 1. In this setup, the letter k actually represents the fraction m1 divided by m2. By using this single variable, k, we significantly reduce the complexity of our equations. Once we perform our calculations and solve for the value of k, we can easily convert it back into a standard ratio format. This streamlined approach is exactly what we are going to apply in the step-by-step procedure on the next slide. Now that we've established that we are moving from finding a point to finding the ratio itself, let's look at the core concept here on slide 2. Step-by-step procedure to find the ratio. Now that we understand why we use the k to 1 notation instead of two separate variables, let's walk through the actual procedure you should follow whenever you are faced with a problem like this. I've broken this down into 6 clear steps to guide you. Step 1. Assume the ratio. Whenever you start, begin by assuming that the point P, with coordinates x and y, divides the line segment OB internally in the ratio k to 1. This is our starting assumption that simplifies everything. Step 2. Apply the section formula. Now, we use the simplified version of the section formula that we just discussed. For the x-coordinate, x equals k times x sub 2 plus x sub 1, all over k plus 1. And similarly, for the y-coordinate, y equals k times y sub 2 plus y sub 1, all over k plus 1. Step 3. Choose one coordinate. This is a very important tip for saving time. Since the point P must satisfy both the x and y equations, you don't actually need to work with both at the same time. You only need to pick one of them to solve for k. My advice: look at the numbers provided and pick the coordinate that looks simpler or has fewer negative signs. Step 4. Solve for k. Once you've picked your coordinate, substitute the known values. That is your x, x sub 1 and x sub 2, or your y, y sub 1 and y sub 2, into your chosen equation. From there, it's just a matter of solving the linear equation to find the value of k. Step 5. Express the final ratio. Remember, the value you find for k is not the final answer in its very final form. The value of k represents the ratio. So, if you calculate k and get a fraction, like a over b, you should write your final answer as the ratio a to b. Finally, step 6. Verification. While this is optional, I highly recommend it to avoid those common mistakes we will discuss later. Take the value of k you just found and plug it into the other coordinate equation, the one you didn't use in step 3. If the result matches the given coordinate of point P, you can be absolutely certain your calculation is correct. Now, let's put this entire process into practice with a real-world example on the next slide. Real-world application example. Now that we have understood the theory and the step-by-step procedure, let us apply these concepts to a practical, real-world scenario. Imagine a straight highway connecting City A and City B. Along this highway, there is a petrol pump, which we will call point P. On our coordinate map, City A is located at the coordinates 2, -3. City B is at -4, 7, and the petrol pump P is positioned at -1, 2. Our objective is to determine the ratio in which the petrol pump divides the distance between these two cities. To solve this, let us follow the systematic approach we just discussed. Step 1, we must identify our given values. From our coordinates, point A with x sub 1 and y sub y1 is 2, -3. Point B with x sub 2 and y sub 2 is -4, 7. Point P, representing our petrol pump with x and y, is -1, 2. Following the method from our previous slides, we will assume the ratio is k/1. Step 2, we will apply the section formula. Since we want to find the ratio, it is easiest to use the formula for the x-coordinate. The formula is x equals the quantity k times x sub 2 plus x sub 1, all divided by the quantity k plus 1. Substituting our known values, we get -1 equals the quantity k times -4 plus 2, all divided by the quantity k plus 1. Step 3. Now, we solve the linear equation for k first. We multiply both sides of the equation by the denominator, k plus 1. This gives us -1 times the quantity k plus 1 equals -4k plus 2. Distributing the -1, we get -k minus 1 equals -4k plus 2. Next, we rearrange the terms to isolate k by adding 4k to both sides and adding 1 to both sides. We arrive at 3k equals 3. Dividing both sides by 3, we find that k equals 1. Step 4, we can now determine the final ratio. Since we found that k equals 1, our ratio of k to 1 becomes 1:1. This result is quite significant. It tells us that the petrol pump is located exactly at the midpoint of the highway between City A and City B. Step 5, as I recommended in the procedure, let us perform a verification using the y-coordinate to ensure our calculation is accurate. We use the formula y equals the quantity k times y sub 2 plus y sub 1, all divided by the quantity k plus 1. Substituting k equals 1 into this formula, we get y equals the quantity 1 times 7 plus -3, all divided by the quantity 1 plus 1. This simplifies to 7 minus 3, all over 2, which is 4 divided by 2, resulting in 2. Since this calculated value matches the y-coordinate of our petrol pump, which is 2, we have successfully verified our result. Key takeaways. First, let's revisit the k/1 method. As we saw in our step-by-step procedure, instead of dealing with two separate variables, m sub 1 and m sub 2, we assume the ratio is k/1. This is a powerful algebraic shortcut because it reduces the number of unknowns, which makes your calculations much cleaner and less prone to error. Second, keep in mind the concept of coordinate independence. You might have noticed in our highway example that we chose to solve for k using only the x-coordinate. That is perfectly fine. Because the point P must lie on the line segment, the ratio will be the same whether you use the x-coordinates or the y-coordinates. You have the freedom to pick whichever one looks easier to calculate. Finally, let's talk about how to interpret your result. The value of k tells a story about where the point is located. If you calculate k and find that it equals 1, it means the ratio is 1:1, which tells you that the point is exactly at the midpoint of the segment. However, if k is a fraction, it indicates that the point is positioned closer to one of the endpoints. Now that we have worked through that practical example, let's take a moment to recap the most important points from today's lesson. Before we wrap up, I want to point out a few common pitfalls that students often encounter, so you can avoid them in your upcoming assignments. Common mistakes to avoid. Now, as we wrap up this lesson, I want to pause and discuss some common pitfalls. Even if you understand the concept of the k/1 ratio, these small errors can lead to incorrect answers. First, watch out for incorrect substitution. A very common mistake for beginners is swapping the x1 and x2 values. To avoid this, always double-check that x1 is assigned to your starting point, point A, and x2 is assigned to your ending point, point B keeping your endpoints organized is crucial. Second, be extremely vigilant with sign errors. When you are cross-multiplying to solve for k, a single misplaced negative sign can ruin your entire calculation. For instance, remember that -1 multiplied by the quantity k plus 1 results in -k minus 1, not -k plus 1. It sounds simple, but this is where most marks are lost. Third, don't forget the final ratio form. I have seen many students perform the algebra perfectly, find that k equals 2/3, and then simply stop there. Remember, the question asks for a ratio. You must convert that fraction into the final ratio format, which would be 2:3. Finally, avoid calculation overload. You don't need to solve for both the x and y equations at the same time. That just creates more opportunities for mistakes. As we discussed in our step-by-step procedure, simply pick the coordinate that looks easier to work with to find k, and then use the other coordinate only as a way to verify your result. If you can avoid these 4 traps, you will find that determining the ratio of division becomes a much more straightforward process.